In this video, we're going to take a look at the get operation. So the get operation. According to our API, it's supposed to return the value paired with a key. So what does that mean? Basically, what that means that so on the side, right? Somehow I have this idea, right, that I have these different keys in my table, right? And for example, maybe I have this key 5, and key 5 maps to the word I don't know, cat. Okay, number 5 matches to cat. And so I would like to be able, right, to look at my tree, right? My tree is built from those nodes we talked about earlier. Every node has a key, it has a value. Find, this, right, find cat from the number 5. That's what I'm supposed to do, right, at the highest level. So what does that mean in terms of my picture here, right, in terms of the data structure that I'm dealing with? Well, it means I basically want to find my way to this node over here, this 5, and return it, right? Return it, take a look at what is the value associated with it, right? So I have to navigate through this tree based on the key, which is 5, till I get to the node, and once I have the node, I can reach inside and I can take out that value. So that's what I want to do. All right, so let's assume for a second, right, that we want to do this, right? We want to find the number 5. What should we do? Well, looking at my tree, I really only have one choice, right? Initially, right, if I were to look at this, right, by hand, right, that's what we're going to start with, right? When we talk through these operations, we'll try to do them by hand, right, before we look at the code. Looking at this tree, right, what do I do? Well, I only have one place to start. I have to start at the root, right? So I start over here. It's like, well, I'm looking at the root. What do I do? I want to find the node that has the number 5. So what I could do, right, is I could say, oh, okay, I'm looking at this node here. This node may or may not contain what I want. So I'll look at its key and compare it to the key that I'm looking for. In this case, it's a mismatch, right? 5 is not equal to 8. So I'm not done yet, right? If I was done, I could go ahead and say, hey, whatever is the value associated with that node that I'm looking at, return that value, you're done. Okay, that would be nice. Unfortunately, that isn't how it's going to work. So what I would do then is potentially look at the node in terms of its key versus the key I'm looking for and try to see which way I can maybe go. Because remember, I have that left-right rule. So if the key I'm looking for is less than the key that I am currently looking at, well, then I should basically go to the left, right? It's like, well, here I know this, right? I know 5 is less than 8. And over here, right, my tree is basically kind of divided into halves, right? I have the left half, the right half. This side is basically large, this is small. Well, if 5 is less than 8, that implies that 5, if it exists, right, may not exist, or I may not be able to find it, 5 would be over here, right, in the smaller region, right? So that's where I want to go. It's over here, right? So I go basically to the left-hand side, right? I have now, a new node I'll be looking at, right? So all of a sudden, it's like, say I'm looking over here. Well, then basically I'm good to go, right? I move to the left, right? The kind of smaller area here. I compare what I'm looking for, that 5, with what's there. It's also 5. There's a match, right? That means I've found what I'm looking for. So that's one of the simplest things I could have happen. Let's maybe try searching for another value. So let's try searching, for example, for, I don't know, the number 1 and see what happens. So let's see. Let me not erase too much of my drawing. So let's say, right, I want to search for the number 1. How would our trace maybe look? Because I said before, right, is that maybe it doesn't actually exist. All right, so starting with our root, right, we basically want to say, hey, am I at the node that I want to be at, right? Is the key that I'm looking at the same as the key that I have, right? So this is basically, where I'm looking, right, is the arrow I just drew, versus the circle over there with the 1 in it. That's, what I want to find. Well, in this case, right, there's not a match, right? But I do learn that 1 is less than 8. So then I get to go, now I get to the left-hand side. So that narrows me down, right? I know that I have to be on this side over here. Then, right, I'm looking at the 5. The question is that what I want? Well, 5 not equal 1. It's not. So we need to keep on going. So then we basically do a check around. We figure out, oh, hey, 1 is less than 5. So that means, right, that I need to go over here, the left-hand side. Now I'm looking at 2. Let's erase this over here. Well, is it what I want? It's not. Got to keep on going. But I learned that 1 is less than 2. So I go over here. The little box I just drew doesn't have any nodes inside of it. What does that mean? It means it's not there, right? It means I've searched for a node that doesn't exist in my tree. So whether my node exists in the tree or it doesn't exist in the tree, I'll still be able to find basically, well, in either case, what ends up happening is I end up being able to find where it's supposed to be, right? So I basically go through a tree, right? I'll end up, wherever it is, I end up at the very end, right? Either there'll be nothing there or there'll be a node there. I'm going to look at the place where that value would be if it was in the tree, right? Initially I looked for 5 and I got led to 5 in the tree because it existed. Here I looked for 1, which doesn't exist in the tree, and I basically got led to the place in this tree where it would be if it did exist. So this is very nice, right? And this just comes from our left-right rule. All right, so this is kind of our basic mechanism. Right? This is what we would like to do, right? We'd like to use that left and right rule, right, to define where I look at my graph, right, or where I look at my tree, right, to find out where this element is supposed to be. And it will be kind of, in terms of performance, it will be a rather nice thing to do, right? Because all of a sudden what we'll notice, right, is like so like the first time through. The first time through, right, I went to the left, I basically skipped out on 10, right? I didn't have to worry about anything in there. I also skipped out later on 7. So these regions of the graph over here, right, the right-hand sides, I just kept on skipping, which is nice, right? All of a sudden I don't have to visit every node in the graph, I only have to visit some subset of them, right? So in terms of performance, this is rather nice. All right, so let's take a look at the code. So here's the actual implementation for Git. And we have two functions, which are basically, well, one's recursive, the other one's kind of a helper method. So we have initially, right, basically get for a key. Okay, get and wants to return a value. And in here, right, what we have is this over here, which is a call to get root comma key. Basically, we have two functions that are named the same, one which has one argument, one which has two arguments. The first one, right, is this one over here, which just takes in the key, right? What is it you're looking for? The other one takes in not just the key we're looking for, but the root of the tree we're looking for inside of. Okay, that's what X is. X is the root of a tree that you're looking for this particular key. So looking at the code, first thing we do is we check is X null. If I'm looking for an empty tree, if I'm looking for a node in an empty tree, I'm not going to find it. So I just return null. Okay, so this is basically the empty tree case, right? Is this stuff over here? All right, so let's say we're not looking at empty tree. What do? We want to do a comparison. So we want to look at basically our node, right, and figure out is it what we're looking for or not, right? Or is it smaller or is it larger? And so let's say, for example, that we can do the comparison and what we find out is the node that we are looking for, right, that key that we're looking for is less than the thing that we're looking at. Well, if it is less than, right, that's this case over here, right, what we do is we go to the left. So notice we make basically another recursive call, right? So we're saying, okay, you know what? I didn't find what I'm looking for, so when I do that get, so that get basically becomes a return of get on the left-hand side, right? So we're deferring to that, calling that thing again on the left-hand side, because the left-hand side should be where it belongs, right? Versus, right, maybe I find that the thing I'm looking for is larger than the node that I'm currently looking at. Well, if it is the case, then I want to go to the right, right, which is this over here, right? So go and look at the right-hand side of the tree, see if it's there, right? If it is, return it. Otherwise, right, if we get down to the very end, basically what that means is you are what I wanted, right? So I looked for a key, right, and that key that I'm looking at is the same thing, right? They are equal. In which case, if they're equal, I just do a dot value, right, to return, the value associated with that key. So yeah, that's the overall algorithm, right? And so the primary heavy lifting is done here. The other one, right, is just a helper function that says, okay, you're going to start at the root, right? And then as I run, right, I kind of move down my little arrow, right? X is the arrow, right? So over here, right, in this example, when I did stuff like this, that's basically my X variable, right? Same thing. All right. So yeah, if you want, right, you can look in the book. The book has a few more diagrams of this, right? Basically, right, they kind of make a distinction between a successful search, right, which is the first thing we did when we looked for the 5, right? We basically are looking through an element, right, that's already there, right, in the tree, right? And so when I do my left-right navigation, I will find it. Versus the alternative is an unsuccessful search, right, which is looking for something that doesn't exist. And even though, right, so even when we do an unsuccessful search, right, basically what happens is we'll go to the place in the tree where it would be if it was in the tree, right? So it's like we have to go there, right? Because in order to say that a node, doesn't exist in a tree, we need to go to the place it's supposed to be, right? Because otherwise, how can we know, right? We need to go to that specific place. So we do a lot of work, right, to say, oh, hey, there's nothing found. But actually, it'll end up being a little bit useful later on. All right, so that's our implementation, right, for get, right? This is our, we've gone through kind of the concept by hand as well as the code implementation. Hopefully that stuff makes sense. In the next video, we'll look at the put operation.